All right. You remember first semester, give me some of the theorems that we talked about.
Oh.
Extreme value theorem. Bonus if you can tell me, I mean, that was the name. Can you tell me what it was? Did not have to be differentiable. The only one that had to be differentiable was the mean value theorem, but it definitely had to be continuous. If it's continuous, the extreme value theorem guarantees that there's at least one high and there's at least one low. There has to be a maximum. Okay, what you're talking about is if that high is above the x-axis and if the low is below the x-axis, the IVT guarantees that you'll cross the x-axis, right? And then we have the mean value theorem. All right, so for the other half of calculus, for the integral half of calculus, we really only have one. Don't need to answer you. We only have one big theorem. This is the fundamental theorem of calculus. All right, so there's only one this semester. We're going to spend a couple days on it. We're just going to dabble with it today. We're going to revisit Math 9. So you've been working on that for a little bit. We're going to talk more about positive and negative area and how that impacts both net and total areas and using our definite integrals. So just as a recap of what we've done this week, we have now defined the integral symbol. The integral symbol gives exact values of area over a closed interval. Okay. You do have to be continuous for this to work. There can be no breaks, no holes, no asymptotes, no jumps, no gaps. It must be continuous for this to happen. And we've only focused on relative to a horizontal axis so far. So we have done that with geometry, rectangles, trapezoids, paraboloids. We've done semicircles. We've done triangles and squares. Okay, and then we've also learned how Math 9 can confirm that. So looking at a problem like this, from -1 to 2, x sine x relative to the dx axis. Why do you think, if you were Math 9, would be a better option here?
It's hard to split it into like equal groups to get an exact number using like a trapezoid or anything else like that.
Okay, yeah, the shapes do not work well in x sine x. Okay, take a look at x sine x in your calculator. Okay, I want you to go ahead and grab that. We want to make sure we understand what the visual representation is here. Make sure you're in radian mode. Go ahead and set your window just to go from -1 to 2. Your y value would normally be set from -1 to 1 for sine, but because you do have x as a multiplier, you'll need to go a little bit bigger than that. So your window on y can be, or x can be -1 to 2. Y, why don't you go like -3 to 3, just to give yourself enough space, but do make sure you are in radian mode. And then take a look at that graph.
Why couldn't we use the Simpsons?
Why couldn't you use what?
The Simpsons?
It will be the most accurate. Okay, but it's still not going to be absolutely accurate. It will be the closest, but it's not going to be absolutely. It's still just an approximation. Okay, so go ahead and let's sketch that. So going from what I'm seeing from -1 to 2, and if I've got 0 here, okay, I'm seeing a graph that comes down, is instantaneously tangent to 0, which means it skims right off but does not cross, and then comes up and is going like that. Okay, that's what I'm seeing on my graph. All right, so Math 9 is the best option because geometry will not get us an exact value. Geometry could get us close. We could use paraboloids as Simpson's method to get us close, but Math 9 is going to be exact for us because it is not like a linear piece. It's got curves to it. So the area we're looking for is always the area under the curve or between the curve and the x-axis. So this is what we'll be looking for in square units. So go ahead and evaluate your Math 9. And then maybe Reagan, you can give us your answer once you've got it. Oops. All right, so the area here, 2.04, and then 3 would be fine. 3 would be the shortest amount of decimals. Okay, you want at least 3 decimals. So you look at the 4th decimal, so it was 2.7, so I could make that a 3. All right, sometimes area, or what you're looking at, dips below the x-axis. And yesterday we talked about how we consider that to be the negative area. So you need to understand the difference between net area and total area. If you are asked for net area, you keep the signs as they are. Okay, net area would be the positive and the negative area just as they are with no changes to that. Total area involves an absolute value. Total area would throw absolute values around the parts that were negative. So if we go down to our graph and we want to apply an absolute value to that, what it's going to do is it's going to make the negative area reflect over the x-axis, excuse me, and then it's going to make the other negative area reflect, and so everything then becomes positive. And so net area will always be less than or equal to the total area. Okay, less than or equal to. When would net area and total area ever be equal to each other?
The entire thing is above the
If everything was already positive to begin with. Okay, then those two things would be equal. But if you have any part of that area that would be less than, then just so you got to keep those definitions straight in your head, because like on a multiple choice, they'll have both of the answers. They'll have the net area and the total area, and so you would need to make sure that you're giving the right one. On a Math 9 on your calculator, if you were evaluating that, you would break it up into pieces. You would do a Math 9 for every little section, okay? And then throw an absolute value around the section that was negative if you needed that. So this is called integrating over subintervals. So I want you to look at these key words here. Words like partition. Partition means break it up into subintervals. And then number 2, integrate over each subinterval. So do them separately and then add up the results, what you get, so you have an absolute value. Just want you to remind you where the absolute value key is on your calculator. On your Math 9, you would start your integral first. So go ahead and hit Math 9. And skip the bounds for now and then go to where you would put the function in the middle. Then once you're sitting in that middle function part, then you're going to go back to accessing your math key. But this time, instead of going to Math 9, go Math and then go over one table to the numerical table, and it should be the first one under that option. And then that would put the absolute values where you would want it. Okay, does anybody have questions about that? So the absolute value, some people do that wrong and they start the absolute value first. Okay, you can't start your absolute value first. The absolute value has to go on the interior part, and then you put the f of x in there. And then you have your bounds set from A to B. Okay, so let's find the total area now in this next question. So total area means I need to account for anything that's negative. So go ahead and change your y1, and your y1 is now going to be x times sign of quantity x plus 1. And the window's different. The window I've given you this time is from 0 to 7. So go ahead and take a look visually at what that looks like. So 0 for your lowest value, 7 for your highest value. And I always feel like it just helps me to have an idea of what I'm looking at. Okay, we haven't talked about the y yet. My y is still set to -3 to 3 like it was last time, but that's not good enough on my graph. I don't know if you can see it from there, but mine is -3 is not, doesn't cover the bottom dip. So I'm gonna go -5 to 5 for my y window. All right, and then I just try and sketch. It does not have to be perfect, but just give a decent idea of what this is gonna look like. So I've got positive area in two regions, but I have negative area in another. And so I need to partition this by figuring out where these 0 values are and storing them in our calculator. So go to second trace and calculate the first 0. What would you estimate it to be based on just looking at the graph?
0. Or
Well, yeah, 0 is on the origin, but I mean the next one where it's crossing from positive to negative.
2.25.
Okay, somewhere a little bit more than 2. All right, so go ahead and grab that. I get, oh, somebody else, tell me what you get. 1416, so 2.142. Okay, now quit your screen and store that value. Store it in alpha A. Okay, quit your screen and then hit store alpha A. So that value is remembered in your calculator.
Where's not working?
Store right above the on button. You gotta be, wait a minute, it's not working.
There we go.
Okay.
Takes a couple of tries.
Okay. Right above your on button, right there. Store. Anybody else not finding it? Got it? Okay, did you calculate the 0?
Quit really fast. So once you calculate your 0, you have to quit instantly and then do it. And you can't like you have to go back.
It's fine. And then
Yes,
hit
I'm here.
OK.
So volume, and I go to
You have to tell it where to store it. So hit OK.
Yeah, you go ahead. Store. Alpha.
There you go.
Oh, I just.
Yeah, there you go.
Oh,
Well, you did put a
Sometimes it takes somebody like looking at it for me to store it.
No.
You do it. It's just like tries.
Oh, but it's not the same number. Did you calculate the?
Wow, she's dedicated.
Oops, my calculator can't trace.
Why'd you laugh at
All right, so go ahead and label. On an FRQ, they're going to want to know what letter that you use, so go ahead and label that. All right, and then let's repeat it for the second one. So second trace and calculate your second x-intercept, your second root, which I'm going to estimate to be somewhere in the ballpark of, I don't know, 5.3. I get 5.283. So this one is B equals 5.283. So then, again, once you have it, quit, store, and this one time do alpha B. So both of them are stored. Okay. So your window is too big. Your window should be 0 to 7. Window. 0 to 7. There you go. Okay. Yeah, did you store it? So you have to find, you have the second trace. You gotta find that value.
Tyler's racking up the hours. That's 7 hours less than that. We're gonna get like.
Okay, so once you have that value, then you have to quit.
We're gonna get over 12 today.
Quit.
Well, I don't, you know what, it's done.
National, well, yeah, come on. There's priorities here, you guys.
You wanna quit, you wanna okay, now store and alpha.
You want us to learn who you are?
Store.
Yeah. Oh my god. I think that was the best.
All right. Which integral needs to have absolute values? The one going from
2.142
A
to B.
to B. Okay, so in our calculator, in all on one line, you can type 3 math 9s in a row. Okay, we can do all on one line. We can do a math 9 that's going to go from 0 to A, and then y1 dx. And the next integral would start where? A to B, but what do I have to be special about that one? Absolute value of y1 dx. And then the last one would go starting where? B and ending at 7. And that would just be plain y1 dx. So you could do them one at a time if you want, and just write them down every time, or your calculator can handle all of those in a row. Yeah.
Could you do it so, and one just put absolute value around the function? Does that still work?
Long term, that will work, yes. But in terms of, I'm trying to get you all the points you can for the FRQ, and that's what they want to see. They want to see that you understand what it's applying to. Okay, so go ahead and try that, and let's see if we all get the same answer. Okay. Oh, I haven't done it yet, so let me see. Oops. We'll just go for your last test grade, right?
Yeah. No.
All right, I get 16016. Okay. All right, if you don't get that, then let me come later and take a look at your calculator. Okay, so let's try comparing the net versus the total. Okay, let's compare the net versus the total. Now, this time, we're going to do it without our calculators, okay, because it's just a parabola. No, we'll do it with our calculators. But we'll go on the interval from 0 to 6. So remember that a parabola, where's this parabola starting at?
4.
Okay, so it's starting at 4 up here. And then it's crossing the x-axis and it's going way down and dipping pretty low by the time it gets to the number 6. So we only have to break this up to 2 different integrals. Where is it crossing the x-axis? Again, we don't need our calculator to do that for us. 2, okay, good.
Yeah.
Okay, it's crossing the x-axis at 2. And then we have all of this area down here. Okay, so the difference here is that my net would simply go from 0 to 6. And I would have of y1, I'll call it the right thing, 4 minus x squared dx. That'll be my net. Do you expect that to be more positive or more negative?
More negative.
Probably more negative. Mine's not quite perfectly drawn to scale, but the negative is quite a bit bigger than the positive part is. And then when we do total, we would set it up and break it up into 2 integrals. Our first integral would go from 0 to 2, and it would use parentheses. And our second interval would go from 2 to 6, but it would use absolute values. Okay, so we set that up like that. When you have your calculator to use, you're still required to write down the integral. You don't have to show any other work. You don't have to show like area computations or anything, but you just have to write the format for the integral, and then you can let your calculator actually determine that. All right, so go ahead and practice that. Practice doing a math 9 for the net, and then practice doing a math 9 for the total. All right, so we end up with, I confirm, negative 48 for our net, and we expected that to be more negative than positive, and it was quite a bit more negative. Were you able to get as far as getting the total?
I got 58.7.
Okay, we're going to need a few more decimals than that. You always have to go to at least 3 more decimals.
6, 6, 7.
All right, so 6, 6, 7 would be fine. Okay, 2/3 is the fraction for that. Okay, any other questions on that?
On the AP exam, are they looking for the decimal or can we just say 2/3?
Any equivalent answer? Okay. All right, two more things, I think.
My hands are so shaky.
All right, let's see. Find the total area using two functions at a time. Okay, so now you're going to need a y1 and a y2. So make sure you make room for both of those. Go ahead and put a y1 and a y2 in. We're going to have the sign of x shifted up 1. And then we're also going to have just the linear line 2 minus x.
Are we putting this in my line too?
Y1 and Y2, yeah, you'll need both. And then you can set your window from 0 to 2 this time.
No, there goes my TX.
Oh, I guess you could have done it at Y3 if you wanted.
No, I have another TX for my
Oh,
3.
okay.
I just had them like stacked. I was
Uh-huh.
like,
And then a dx after that, sure.
Yeah. And then a 0 and like Y5.
Uh-huh. All right. So if I'm going from 0 to 2, my line is just going to look like this. But then my sign graph starts at the number 1 and then ends up crossing over. All right, what do you think is the most important thing to find first? Huh? Yeah, but first, before I can find the area. Yeah, where they intersect. I need to know where these two things cross each other. All right, so we're going to do a second trace. This time we're going to trace to where the intersection is. So that would be arrowing down to number 5. And finding the intersection value. Rain, can you let me know what you find once you've got it?
0.51097.
Okay. 0.51, what came after that? 0.9, so that'll be 0.511. We want to store that as well. Store this and go ahead and put it back in alpha A to override what we had before. So once you've determined that, you can quit. And then you want to store that value in your alpha A. And then label it that that's what A was. Okay, so we're trying to find the area between the functions. So we want the area right in here. This is going to use subtraction. Okay, which is the higher function at the beginning?
The
2 minus x, where do you have that stored in your calculators? Alpha 2? Y2 probably. Okay, and so what you would do is you'd set up an integral that went from 0 to the intersection of A, and in that section the y2 is the higher graph, and you're going to subtract the y1 as the lower graph, and then you put dx. It's a subtraction because you're taking away the area. You're taking away the area underneath the y1. But then what happens at alpha A?
And they flip.
They flip. Okay, so then we do, starting at alpha A and going the rest of the way to the number 2. And then for these, we flip and we take, okay, y1 minus y2. And then evaluate that. So you want to keep the area that's under the higher curve, but erase or delete the area that's under the lower curve, and that's happening at that intersection spot. So go ahead and practice doing that using your Math 9 on a home screen. Yeah.
So what are we trying to like find the area of?
Okay, so if we just, if we just had y2 like that, then the area would be everything under y2 all the way down to the x-axis. So it would be all of this area, all the yellow stuff. Okay, that would be all of that. But what I want to keep is the area between them. So I want to subtract everything that's under the line, the sine curve. And so that's why I use subtraction. And that subtraction then, and that leaves me with just the little yellow bit that's left. Okay, so we're trying to find the total area between the two functions, so the area that's captured in there. Okay, and then we flip, because the graphs crisscross, we switch our subtraction as well. So remember, this is the y2 that's on top, and this is the y1 on the bottom, or I'm assuming that's what you did in your calculator. But then they flip, and this is the y1, and this is the y2. So we flip our subtraction. Does anybody have an answer for that? 1.922 is the area of the green and the yellow combined. Okay, last one. Find the total area between the parabola 5x minus 2x squared and g of x equals 2. What shape does that look like? Okay, that's just a constant line. And maybe use geometry this time is the suggestion. So let's take a look at what that parabola looks like. You can go ahead and put that in your y1. Okay, that parabola 5x minus 2x squared. But what I did not tell you this time is I did not tell you what the boundaries were.
Well, we'll see that.
Okay, but you'll see it when you draw the graph. All right, so go ahead and take a look at this graph. Okay, so we get a parabola that looks like this. And we get a line of 2 that's going straight across. So we need to figure out where these two things cross. So I've got y1, and my y1 is going to be the 5x minus 2x squared. And my y2 is just going to be the line there. And I set up my intersection points because I am looking for the area between them. So there's a couple ways you can do this. Okay, first let's find the intersection. All right, well, once you find your intersection, then you're just going to set up your subtraction. And all we're doing is the stuff bounding in between. I'll write down what that would look like. Okay, so which one would come first in the subtraction? y1, right? And then y2 would come second. And then once you have your intersections stored, you'll have A labeled as one of them and B labeled as the other, and then you're going to go from A to B.